Hi all, this lecture is going to be on section 1.3 of Hurley's Intro to Logic, and it will be about deduction and induction. Up to this point in the course, we've learned about how, given an argument, how to distinguish between the parts of arguments, premises, and conclusions, and we've talked about how, given a passage, how to figure out if it's an argument or a non-argument, and what the different types of non-arguments are. Today we'll start talking about two different types of arguments and how to distinguish between those two different types of arguments. Those two different types, deductive and inductive arguments. So the book gives us this definition for deductive arguments. A deductive argument is an argument incorporating the claim that it is impossible for the conclusion of the argument to be false, given that the premises are true. And an inductive argument, it says, an inductive argument is an argument incorporating the claim that it is improbable that the conclusion be false, given that the premises are true. So note the subtle difference between deductive and inductive arguments. In these definitions given, it's just a couple words, right? So impossible and improbable. So to put this another way, what a deductive argument is trying to do is guarantee the conclusion. So it's dealing with certainty, while an inductive argument is trying to prove that the conclusion is likely. So an inductive argument deals with probability. Deductive arguments deal with certainty. Inductive arguments with probability. So for the rest of this lecture, we'll be trying to figure out what clues we might use to distinguish between these deductive arguments and inductive arguments. All right, so the steps for differentiating between the two. First, look for the occurrence of indicator words. We've talked about indicator words before when we were trying to figure out which parts of arguments were premises and which parts of arguments were conclusions. We had specific indicator words for premises and specific indicator words for conclusions. Now when we're trying to differentiate between inductive and deductive arguments, we'll have other indicator words. The indicator words for deductive arguments would be words that indicate that this argument is dealing with certainty, right? So words like it must be the case that, or it is certain that, or it's impossible for the following to be true or false, or this follows necessarily or of necessity. Any of those terms would give us a hint that the argument that we're looking at is probably deductive. On the other hand, if we see words dealing with probability, words like it's likely that the following is true, or makes it unlikely that the following is the case, or it is probably the case, those words would usually indicate that the argument that we're looking at is inductive. Now, though that's a good first pass to see if an argument is inductive or deductive, but like we've talked about with indicator words for other purposes, indicator words are imperfect guidelines because people often speak in ways that they don't actually mean. So sometimes an arguer will exaggerate the certainty that we should come to, the certainty with which we should accept the conclusion based on his argument, sort of trying to fool us that their argument is deductive when in fact it's inductive. So these can be a good rule of thumb, but we'll also want some better, more precise tools for determining whether an argument's inductive or deductive. One of these tools, the next step we should take after looking for indicator words, is we should try to look at the strength of the inferential link between premises and conclusion. We've talked about what an inferential link is in the last lecture. An inferential link is the support that the premises give the conclusion. So the strength of the inferential link is something that we can look at to determine if an argument's inductive or deductive. If it's the case that if the premises were true, they would actually guarantee the truth of the conclusion, then we can be certain that we're looking at a deductive argument. If it's not the case that the truth of the premises would guarantee the truth of the conclusion, we could be looking at an inductive or a deductive argument. We'd have to get into it a little more, use some other tools to determine which type of argument it was. But if the truth of the premises would actually guarantee the truth of the conclusion, we know the argument's deductive. The final way we can try to differentiate between the two is there are very common forms of inductive arguments and very common forms of deductive arguments. And if we can figure out which specific type of form the argument has, then that's a really good way of determining whether the argument's inductive. So here on the left-hand side of the screen, I'll put up a list of the 5 deductive argument forms and the 6 inductive forms. So for deductive forms, we have arguments from mathematics, an argument from definition, and then we have 3 different types of what we call syllogisms. So a syllogism is a fancy word just meaning a deductive argument with 2 premises and a conclusion. So we have 3 different types of those: categorical syllogisms, hypothetical syllogisms, and disjunctive syllogisms. And then for our inductive forms, we have 6 types. We have predictions, arguments from analogy, generalizations, arguments from authority, arguments from signs, and causal inference. Note that that word is causal, not casual. Causal inferences is our final type of inductive argument form. So for the rest of this lecture, I'll go over each of these individually, talk about what they are and give you some examples. And then at the end of this lecture, you'll have a few quiz questions where you'll have to determine if an argument is inductive or deductive and which specific type of form the argument that I give you has. So let's start with the deductive forms. So first, arguments from mathematics. And I put here in parentheses, not statistical arguments. So mathematical arguments, specifically not the statistical arguments, because as we'll see, statistical arguments are actually generalizations. So those will be inductive arguments. But other arguments from math will generally be deductive arguments. So take the following. Premise 1, figure A is a right triangle. Premise 2, 2 of its sides have a length of 1 foot. And the conclusion, therefore, its area is half a square foot. So this is a deductive argument. In fact, we can know it's a deductive argument because if those premises are true, then given the qualities of right triangles and the method we have for trying to determine the area of a right triangle, we can know that the conclusion is guaranteed because we've discovered those rules of triangles, right? So if those premises are true, the conclusion is actually guaranteed. So geometric arguments will count under arguments from mathematics, and they'll be deductive arguments. Take an example from arithmetic. The premise here is 2x plus 5 equals 11. And if we solve, and then the conclusion is, therefore, x equals 3. And if we solve for x here, the only possible answer is x equals 3. So given that information in the premise and the rules of mathematics, we can know for certain that x equals 3. It's the only open possibility. So this is going to be a deductive argument because it deals with certainty. The next type of deductive argument form is an argument from definition. So arguments from definition proceed from the meaning of a word. Take the following example. Claudia is mendacious, therefore Claudia tells lies. Now, if the premise is true here, then it would actually guarantee the conclusion, because what it means to be mendacious is to be somebody who tells lies. So if the premise is true, the conclusion can't fail to be true. It would be impossible for it to be untrue. The third type of deductive form, so the first type of syllogism we're offered is called categorical syllogism. So categorical syllogisms, recall a syllogism is just a deductive argument that has 2 premises and a conclusion. Categorical syllogisms deal with categories of things. And they talk about how many members of the categories have certain qualities. So the words you're going to want to look for to try to figure out if the big hints that you're looking at a categorical syllogism are the words all, some, none, and no, because those would be words talking about how many members of a category have a certain quality. So let's look at some examples here. First argument, premise 1, all men are pigs. Premise 2, all pigs are cute. And the conclusion, therefore, all men are cute. So here we see 3 different categories of things: men, pigs, and things that are cute. And the argument tries to draw a conclusion based about, how those categories fit together, right? So we see the word all there used 3 times. It's talking about all of the members of certain classes and their qualities. Then look at the following argument. 1, some heart attacks are not fatal occurrences. 2, no strokes are heart attacks. 3, thus, some strokes are not fatal occurrences. So here we see the term some and no. And again, these are talking about members of specific categories that have certain qualities. These will all be deductive arguments. They're attempting to prove their conclusion with absolute certainty. All right, the next type of syllogism, the next type of deductive argument form is the hypothetical syllogism. For hypothetical syllogism, what you're looking for are conditional statements. So look for the words if and then. So here's an example hypothetical syllogism. If the Raiders won the Super Bowl, then pigs can fly. Pigs can't fly, therefore the Raiders didn't win the Super Bowl. So this is a deductive argument, and in fact it's a good deductive argument. If those premises are true, they would actually guarantee that the conclusion was true. And the way you can sort of get your head around that this is a deductive argument, that it's trying to prove the conclusion with certainty, is the first premise sort of sets up a rule, right? If the Raiders won the Super Bowl, then pigs can fly. And the second premise tells us about some state of affairs, right? Pigs can't fly. And then if we're given that rule in number 1, and we know that it's the case that pigs can't actually fly, then if that rule is true and pigs can't actually fly, then it has to follow that the Raiders didn't win the Super Bowl. You may recall from our lecture about 1.2 that the consequent of a conditional statement is a necessary condition for the antecedent. So in order for, in this case, it to be true that the Raiders won the Super Bowl, if premise 1 is true, then it has to be the case that pigs can fly. But premise 2 tells us pigs can't fly, so it can't be the case that the Raiders won the Super Bowl if we're given that premise 1 is true. Final type of syllogism we're given is disjunctive syllogism. So here you're looking for a disjunction. So look for either or statements. Here's an example. Premise 1, either Donald Trump or Bernie Sanders will be our next president. 2, Donald Trump will not be our next president. Therefore, Bernie Sanders will be our next president. This argument was written in happier times, but we need to talk about why this is a deductive argument. So remember, in a deductive argument, what it's trying to do is prove its conclusion with certainty. And premise 1 sort of sets up a rule, right? It tells us either Donald Trump or Bernie Sanders. So it gives us a couple options. Either Donald Trump or Bernie Sanders will be our next president. Well, if that's true, and if it was true that Donald Trump was not going to be our next president, then there's only one conclusion that could follow. Bernie Sanders would have to be our president, right? Now, you may be thinking, well, look, premise 1 actually isn't true. There were other options to be our next president. But that doesn't make the argument not deductive. It just means premise 1 could have been false, right? There could have been other options. But this is a deductive argument. If those premises are true, they would guarantee the conclusion. And that means it's actually a good deductive argument, or at least has one type of goodness that we'll talk about later, which is validity. So for disjunctive syllogisms, look for an either-or statement, and then the next statement should either confirm or deny either the either or the or part, and then conclude with one or the other. All right, so now let's take a look at inductive argument forms. So the first inductive form we're given is arguments that try to make predictions. So arguments that are predictions have premises about things that have happened in the past, and then draw a conclusion about something that will happen in the future. Take, for example, the following. California's electoral college votes have been awarded to the Democratic presidential candidate in the last 6 elections. The conclusion, therefore, it's likely that they will be awarded to Democratic presidential candidate in the upcoming election. So given that it's happened 6 out of the last 6 times, we can conclude that it's really likely that that's how it's going to happen in the next election. Now, of course, this isn't guaranteed, right? Even if we had even if it happened in 100 out of the last 100 elections, it wouldn't be guaranteed that it would happen in the next election. But it would be even more likely to happen, given that as a premise, right? So here, when we're making predictions about the future, nothing's guaranteed, but it can be more or less likely. So that tells us that we're dealing with an inductive argument form. Now, one thing to note here is no matter how seemingly certain the event, if it's a prediction about the future, it's an inductive argument and we're not dealing with certainty, we're just dealing with probability. Even if I were to try to construct an argument about the sun rising tomorrow, I still couldn't be completely certain about the sun rising tomorrow. Say my argument was the sun has risen every day for the past 1,000 years. Therefore, the sun will rise tomorrow. If I was going to try to make that argument, it's very, very likely that the sun will rise tomorrow, but other things could happen. The sun might not rise tomorrow. Also, something sort of weird that I'm assuming is that whenever I'm making a prediction about the future, is that events that happened in the past would be some guide to what's going to happen in the future. But then I might wonder, how do I know that events in the past can be a guide for things that are likely to happen in the future? And then if I think about it, I think the only way I know that rule is because I look at events that happened in the past and see that in the past, events that happened in the past were good guides for what happened in the future. But that's, of course, all in the past, right? So maybe the thing that will be different about the future is that when it comes to the future, the past won't be a good guide to the future. Maybe that's the specific thing that's different about what will happen in the future, right? If you're interested in this particular problem, I suggest you look up David Hume's problem of induction. I won't be testing you on that, but just something you might be interested in. All of this is to say that predictions are inductive arguments, right? All right, let's look at our second type of inductive argument. That would be arguments from analogy. So arguments from analogy are based on a comparison between 2 different things. And based on the similarities between 2 different things, we try to reason that they will share a further similarity. So take the following example. Breaking Bad had a protagonist who begins selling drugs due to an unfortunate turn in his life. And Breaking Bad was a great show. The show Weeds had a protagonist who began selling drugs due to an unfortunate turn in her life. Therefore, Weeds was a great show. So note how the argument works. We point to a similarity between the shows. In this case, that they had a main character who you're rooting for, who begins selling drugs due to an unfortunate circumstance in their life. And then we say, well, since Breaking Bad had that quality and it was a great show, and Weeds shares that quality of having a main character who began selling drugs due to an unfortunate turn in her life, that they'll share a further similarity being a great show. Now, arguments from analogy are only inductive arguments because we're comparing 2 different things and saying they'll share a feature, right? But since they're not exactly the same thing, we can't be certain that they'll share all the same features. We can only try to prove with some probable knowledge that they'll share certain qualities. So these will be inductive arguments. Next type of inductive argument are generalizations. So generalizations can work in really one of 2 ways here. One way they can work is there can be a premise about a relatively small population, And then we would draw a conclusion about a larger population that that small population is a part of, right? And we call, when we're dealing with generalizations, the small population the sample, and the larger population the target. So the premise is about the small sample size. The conclusion is often about the larger population of which the sample is part of. More rarely, a generalization can have a premise that's about the percentage of some population that has some quality, and the conclusion about the likelihood that any individual in that population has the same quality. So that's all really abstract, but let's look at some specific examples here. So the first example we'll look at, when asked to address the militaristic ambitions of Syria, 2 Republican senators said we should drop bombs on Damascus, and a third said we should invade. The conclusion drawn here, the obvious conclusion, is that Republicans are all a bunch of warmongers. So here we have a sample, right? The premise is about a sample, specifically a sample size of 3, right? And then the conclusion is about a much larger population having that same quality. As we'll talk about in the next section, a sample size of 3 when you're drawing a conclusion about millions of people is not going to be a large enough sample to justify this conclusion. But this is just to show you the way an argument by generalization works, going from sample size, a relatively, a smaller sample size, to a larger general population. Now, we can't be sure that the general population will have exactly the same qualities as the smaller sample size. So this is why generalizations are inductive arguments. Then the other sort of argument by generalization we can see in the following examples. 60% of the members of the Theta Society drive American cars. Hence, since Christy is a member of the Theta Society, it is likely that she drives an American car. So here we see a generalization where it talks about a population, the percentage of which has a certain quality, driving American cars, and the conclusion that a specific member of that population has that same quality. And if I was going to do this again, I would break up Christy as a member of the Theta Society into another premise, but I didn't. So you can see that arguments from generalization are inductive arguments. The next type of inductive argument we're given is arguments from authority. So arguments from authority work like this. The premise is something that someone has claimed, and the conclusion claims that what that person claimed is actually true. So take the following example. The National Questioner, known for its sensationalist journalism, reports that a young boy in Oklahoma has spoken with Martians. Therefore, we must draw the conclusion that Martians do indeed exist. So the premise here is something somebody claimed. In this case, the National Questioner claimed that somebody talked to a Martian. And the conclusion just says, well, that has to be true based on their authority, right? Now, as we'll see in the next section, we should trust the authority of certain individuals or institutions. We shouldn't trust the authority of other individuals or institutions, and we'll talk about how to differentiate between the two. But for now, this is just getting down the structure of an argument from authority. The premise is something somebody's claimed. The conclusion says, well, therefore that must be the case based on their authority. And just because somebody says something doesn't necessarily mean it's true. But if somebody's a trusted authority, very accomplished in their field, then the fact that they've made some claim does provide likely evidence that it's going to be true. The next type of inductive argument is argument from signs, and that's pretty straightforward. The premise is about what some sign says, or plaque says, or in the example, cereal box says, and the conclusion claims that what the sign says is actually true. So, take the following example. The print at the bottom of this full box of Cheerios says the net weight 15 ounces. Therefore, the contents must weigh about 15 ounces. So the premise tells you what the box says. The conclusion says that must be the case, right? Now, some signs you should trust, some signs you should not trust. Again, we'll talk about that in the next chapter, in the next section. But for now, just notice the structure of an argument from signs. The final type of inductive argument that we're given is a causal inference. So a causal inference is reasoning from one event or state of affairs to a likely cause of that event or state of affairs. So here we're talking about causes and effects, right? Or most usually potential effects to potential causes. So take the following example. Adrian's car has a flat tire. Therefore, someone must have slashed it with a knife. Here, we're going from an event that we see, or a state of affairs that we see, Adrian's car having a flat tire, to a proposed cause, somebody slashing it with a knife. Now, in this case, it's really clear that this is an inductive argument because we're speculating about what must have caused what we're observing. So the effect is something that we're observing, or the state of affairs that Adrian has a flat tire is something that we're observing. We didn't see what caused it, so we have to try to reason our way to what it probably was, right? In this case, the proposed cause, someone must have slashed it with a knife. An interesting thing about causal arguments is even when we see two events that happen, right next to each other in the same area, it's still, when we reason about what the cause was, it's still just going to be an inductive argument. So take the following example. The other pool balls moved when the cue ball struck them. Therefore, the cue ball hitting them was the cause of them moving. Now you might think, well, if I was looking at the pool table, then I saw it with my own eyes. I saw the pool balls move. I saw the cue ball hit them. The pool balls only moved after the cue ball hit them. So it's guaranteed that the cause of the other balls moving was the cue ball hitting them. But it's not the sort of guaranteed, not the standard of certainty that we would need to actually have a deductive argument here. I mean, you can imagine a world where there were other causes for the cue ball, for the other balls moving, even when it looked like the cue ball hitting them was what caused them to move. So you can imagine it's at least possible, right, that there are very strong magnets in the other balls, and a strong magnet in the cue ball. And when the cue ball was approaching the other ball, somebody flipped on all those magnets, making it look like the cue ball hit the other balls and that it caused them to move, when in fact it was the magnets, right? If that's even an open possibility, then what we're dealing with is an argument that's trying to show probable cause, not definite cause, right? It doesn't approach it approaches but doesn't get to the level of certainty we would need for a deductive argument. So causal arguments will always be inductive arguments. All right, so given all that information, let's give you some practice here. So 3 quiz questions will follow. So quiz question number 1, is the following argument inductive or deductive? No theocracies are true democracies. No secular governments are theocracies. Thus, some secular governments are true democracies. So just tell me if that argument is inductive or deductive. Quiz question number 2. Given that the following argument is inductive, what type of inductive argument is it? So I'm telling you this is an inductive argument. Which of the 6 types of inductive forms does this argument have? So the fingerprints on the gun match those of the defendant. Therefore, the defendant must have handled the gun. And quiz question number 3. Given that the following argument is deductive, what type of deductive argument is it? So I'm telling you it's a deductive argument. Which of those 5 deductive forms does it have? If people can talk to the dead, then the dead are still alive. People cannot talk to the dead, therefore the dead are not still alive. All right, so that's the final quiz question. Just to review, today we've talked about inductive and deductive arguments and how to differentiate between them. Remember that deductive arguments try to prove their conclusion with certainty. An inductive argument tries to show that the conclusion is more likely than not, is probable. And the way we learn to differentiate between the two, we talked about looking for indicator words, but indicator words aren't a great guideline. Better tools for trying to differentiate between the two: look at the strength of the inferential link. If it happens to be the case that the truth of the premises would actually make us certain that the conclusion is true, then the argument's deductive. And finally, you can try to determine the specific form of an argument, and I gave you 5 deductive argument forms and 6 inductive argument forms that you can use to try to figure out if the arguments are inductive or deductive. All right, see you next time.